Hello, this is Mrs. Sargent, and this is lesson 4.3, Naming and Formulas of Ionic Compounds with Polyatomic Ions. We previously talked about elements that only had two types of elements, but polyatomic ions is going to refer to more than two types of elements. So a polyatomic ion is a tightly bound group of atoms that behave as a unit and carry a charge. The formula for those polyatomic ions is always going to be the same, but they're going to have a charge to that group. So here we have some examples. We have a nitrate ion that has 1 nitrogen and 3 oxygen and carry a 1- charge. We have a hydroxide ion that has 1 oxygen and 1 hydrogen and carries a 1- charge. We have a sulfate ion that has 1 sulfur and 4 oxygen and carries a 2- charge. An acetate ion has 2 carbon, 3 hydrogen, and 2 oxygen and carries a 1- charge. And then we have an ammonium ion that has 1 nitrogen and 4 hydrogen and carries a 1+ charge. Ammonium is our only positive polyatomic ion that we will be working with. We have some suffixes to the polyatomic ions. The suffix ate, ate, refers to a polyatomic ion that contains more oxygen atoms. The suffix ite, ite, is a polyatomic ion that has less oxygen atoms. So for example, we have a nitrate ion that has 1 nitrogen and 3 oxygen. And we have a nitrite ion that has 1 nitrogen and 2 oxygen. Both carry a 1- charge. The nitrate has more oxygen than the nitrite. Some other examples is a sulfate ion has 1 sulfur and 4 oxygen. And a sulfite ion has 1 sulfur and 3 oxygen. Both of these are going to carry a 2- charge. But as you can see, 8 doesn't refer to 3 oxygen or 4 oxygen because sulfite has 3 oxygen. So it's just in comparing those similar types of ions that you can say more or less oxygen atoms. On the back of your periodic table in the lower left-hand corner, you have this common polyatomic ions list. You will be able to use this on quizzes and tests. And this has the name of the ion, the formula, and the charge. They're grouped by the 1-, 2-, 3- groups, and then our 1+ common polyatomic ion. This will become your friend throughout this unit. So we have some rules for naming ionic compounds with polyatomic ions. The first thing that we need to do is we need to name the cation first. Remember, our cations are positive. And notice I didn't say metal because our cation could be ammonium. The second thing that we need to do is we need to name the anion second. And there is no need to change the ending if it is a polyatomic. However, if it is a single type of element, we are still going to change the ending to I. So we have NaNO3. Our cation is going to be sodium. Our anion is our polyatomic NO3, which is nitrate. We have K2CO3. Our cation is going to be potassium. And our anion is going to be CO3, which is our polyatomic carbonate. We have MgOH2. Our cation there is going to be magnesium. And our anion is going to be our polyatomic hydroxide, which is OH. And then we have NH4Cl. Our cation in this case is ammonium. NH4 is our positive polyatomic ammonium. And then our anion is chlorine. So since it's a single type of element, we're going to change the ending to chloride. Okay, you have 4 more examples. Go ahead and pause the video and try these on your own. Welcome back. We have Ag2SO3. This is going to be silver, sulfite, and then we have NaOH. This is going to be sodium hydroxide. And then we have FeHCO3, and this is going to be iron bicarbonate or hydrogen carbonate, either one of those work. However, iron is a transition metal, so we have to use Roman numerals to determine the charge. Bicarbonate is a 1-, so we can work backwards, so this tells us that iron is a 3+. So we're going to indicate that with the Roman numerals 3. And then we have NH42CO3. This is ammonium carbonate. Both of these are polyatomics. So that's naming with polyatomic ions. The rules for writing formulas with ionic compounds and polyatomics. The first thing that we're going to do is we're going to write each element's symbol or the polyatomics formula. So cesium is Cs and sulfate is SO4 with a 2- charge. Cesium is going to have a 1+ charge. And then we're going to balance out the charges again with the crisscross method. So we're going to take the number from cesium, give it over to sulfate, the number from cesium, give it over, or the number from sulfate, give it over to cesium. So CS2SO4. I cannot simplify this down, even though these have a common denominator, because I cannot change the formula for sulfate. It would only be if there was more than one sulfate that I could simplify it down. So I've balanced out the charges and I've rewritten the formula without charge signs. Magnesium phosphate is going to be Mg, and phosphate is PO4 3-. The charge on magnesium is 2+. We're going to crisscross the numbers from the charges. So this is Mg3, PO4 And we're going to put this PO4 in parentheses and then put that 2 on the outside. This indicates that we have 2 phosphates and not 42 oxygens. You have a few more examples here. Go ahead and pause the video and try these on your own. Welcome back. We have aluminum permanganate. So the symbol for aluminum is Al3+. The formula for permanganate is MnO4, 1 minus. So we're going to crisscross the numbers from the charges. And this is Al, MnO4 in parentheses, and then 3. We're going to have 3 permanganates. Copper 1 plus charge. Sulfate has SO4, and it's going to be a 2 minus. Crisscross. So we have Cu2, SO4. Iron 3 acetate. Iron is going to be a 3+. Acetate is C2H3O2. And it's going to have a 1 minus charge. We're going to crisscross here. So we have Fe in parentheses C2H3O2. We're going to have 3 of those acetates. And then our last example, ammonium nitride, NH4, 1+, and nitrogen is a 3-. We're going to crisscross. So NH4, we have more than one of those. So we're going to put them in parentheses. So NH4 parentheses 3N is our formula for ammonium nitride. All right, you have some practice to work on. You need to work on both practice F and G. You will be having a quiz in the next class, so make sure that you do those practice. Come in and ask questions if you need help. And we'll see you next time.